This video is a study about the project management planning for the proposed sales gallery at City of Elmina, Shah Alam, Selangor, which involving the constructions of 3-story. It outlines the applications of key project management principles, including the project charter, project organization chart, WBS, and site layout plan to ensure effective planning and successful project delivery. The 5 project team members each will develop an individual project plan using the Microsoft project. A comparison was then carried out across the various aspects, leading to the selections of a final consolidated project plan that is best represents a realistic and achievable construction program.
This project is the sales gallery for Unit A1 and A2 at City of Elmina, located at Persiaran Casuarina, Shah Alam, Selangor. The project involves the development of a 3-story sales gallery to support the marketing and sales activity of the City of Elmina Township. In terms of project background, the sales gallery serves as a dedicated customer engagement and marketing center, providing exhibition spaces, show units, sales offices, and parking facilities. The site was selected due to its high visibility and good accessibility, supporting ongoing and future property launches. The main objective of this project are to complete the development within the approved budget and timeline, provide fully functional sales and exhibition spaces, and ensure full compliance with MBSA, UBBL, BOMBA, and utility authority requirements, leading to a smooth handover upon completion. For the project scope, the in-scope works include architectural, structural, and M&E works, roofing, fire protection system, external works, and authority approvals, as well as testing and commissioning. However, the out-of-scope works include landscaping outside the site boundary, decorative interior design, and post-handover operations. The key stakeholders involved are the client and project sponsor, project manager and consultants, main contractor and subcontractors, as well as local authorities such as MBSA, BOMBA, TMB, and Shabas. Finally, the key risks in this project include design errors, material quality issues, weather delays, and machinery breakdowns. The main constraints are the fixed budget, tight schedule, limited site space, and restricted working hours.
This is the implementation of project organization chart for this project. It's being led by developer which is Samrabi Property City of Elmina Development Team, and then we continue by project manager Tan Mei Hua Group 2. And then we divided it into several teams which is design team, execution team, and also compliance and support. For the design team, it consists of architects, civil and structural engineers, and also mechanical and electrical engineers. Meanwhile, for the execution team, it stands of main contractor that we use, which is Mega Constructions Sdn Bhd. For the compliance and support, it stands of quantity surveyor and also authorities and utilities that involve.
Here we have the work breakdown structure, which is separated into 7 categories, starting with Phase 0 strategic definition, which determines the feasibility of whether the project should proceed. Phase 1 preparation and briefing, to develop details such as scope, budget, program, and key requirements. Phase 2 concept design, to prepare initial design proposals, layout, and design strategy. And next we have Phase 3 spatial coordination, to ensure spaces, systems, and components fit together without conflicts. Continuing with Phase 4, technical design, where detailed technical information, drawings, and specifications are produced. Next, we have Phase 5, manufacturing and construction, where the project is constructed in accordance with technical design. And finally, we have Phase 6, handover. The completed project will be tested and handed over to the client, along with any operation manuals.
This is the proposed site layout plan for the sales gallery project. The layout is designed to be practical, safe, and responsive to site constraints. The main site constraints are first, surrounding residential and school areas, second, fixed access from existing roads, and third, nearby green and water sensitive areas. To address these constraints, ingress and egress are clearly separated and controlled by a guardhouse. Noisy and service-related facilities such as waste disposal, wheel wash, and loading bay are placed away from sensitive boundaries. The site office, working rest area, and storage are centrally located for efficient supervision and movement. Overall, the site layout is clear, well organized, and safe, making it easy to interpret and suitable for construction preparations.
For the comparison task, we evaluated the project schedules prepared by all group members using Microsoft Project, focusing on task structure, sequencing, dependencies, and overall realism. Member One's plan was very detailed and well structured, covering all project phases from strategic definition to handover. It shows strong understanding of task dependencies, milestones, and critical activities, making it effective for progress monitoring and project control. While for Member Two's plan focused mainly on the construction stage, the task sequencing followed standard site procedures and demonstrated good understanding of on-site execution, although early planning and design stages were less emphasized. Next, Member 3 covered the full project lifecycle including feasibility studies, authority approvals, and procurement activities such as tender evaluation and award. This reflects real industry practice before construction begins and ensures better project readiness. Member Four's plan was clearly divided by track and easy to follow for site execution. However, it assumed that approvals and design coordination could be completed efficiently, which may reduce realism in actual projects. Wow, Member 5 plan was the most balanced and realistic as it clearly linked design approvals and construction stages in a logical sequence. Therefore, it was selected as the most suitable reference program for the Sales Gallery project.
I will now briefly compare the dependency logic used by five members and identify the most suitable approach. Member 1 uses a highly realistic construction based dependent system. Most activities follow finish to start dependencies with clear phase milestone, ensuring one phase must be completed before the next begin. Technical lag time is also included, such as allowing time for concrete curing. Start-to-start dependency are used in the design stage to allow parallel work while maintaining realism. Member 2 applies a more independent approach. Many tasks have no predecessors and can start immediately. However, the use of manual scheduling and fixed start dates weakens the dependency logic. Member 3 uses a balanced and professional plan focused on client requirements. Waiting time is built into longer task duration instead of using lead time. Prioritizing quality. Next, Member 4 emphasizes authority approval. All tasks depends on charter approval and a 90-day authority approval, which correctly prevent early construction works. Finally, Member 5 uses an aggressive parallel strategy to shorten the schedule, but it may increase risks. Overall, Member 1's plan is the most suitable as it best reflects real-world construction logic, risk management, and professional scheduling standards.
In duration aspect, Member 1 has the longer durations, 557 days, due to a very conservative planning approach. It has full rebar step breakdown and extended approval period, increase the realism but reduce the efficiency for a scallop scale project. The construction phase is appropriately the longest. It also have a correct applications of Selangor public holidays and standard working hours. Both improve the realism, but missing of 2028 holiday will slightly affect the accuracy. For Member 2, it has an unrealistically short overall duration, which is less than 3 months. The poorly balanced phase duration, especially an insufficient construction period. This is due to the major logic and sequencing error, which is the handover before the construction completion. Besides, the incomplete holiday calendar will result in an overly optimistic schedules. These have a high risk of delays and poor schedules credibility. For Member 3, it has the most realistic and well-balanced durations, which consists of 316 days. It has a logical phase-wide time allocations with adequate construction duration. It also has a proper inclusions of Selangor public holidays and standard working hours. This enhances the credibility. This member achieve a good balance between the efficiency and risk management. For Member 4, it has a relatively long and highly sequencing schedules, which is 374 days with minimal overhead. It has an acceptable calendar setting, but incorrect efficiency and sequencing will reduce the credibility. The construction will extending beyond the testing and handover indicate the fronts of the coordination. The holidays and working hours is correct. The duration is reasonable, but schedule's logic is unreliable. For Member 5, it has a reasonable total duration 254 days. The first duration is acceptable, but lack of Selangor public holidays assumptions lead to an overly optimistic calendar. The correct working hours is applied, but missing holiday will significantly affect the duration's accuracy. So in overall conclusions, the Member 3 schedule is the most achievable and realistic. It has a balanced time efficiency, reduce the risk like the delay, and correct calendar assumptions. In key milestone, Member 1 used too many milestones at subtask level with color coding. While this enables a very detailed tracking and visual cluster, but it makes it hard to focus on the key control points like the approval, major completions, and handover. This level of detail is impractical for routine monitoring and reporting. While for Member 2 and Member 3, both member does not include the milestone. This results in poor schedule control, weak progress tracking, and low transparency. This making it difficult to report the project status to the stakeholder. For Member 4, it adopts a balanced milestone strategy with milestones at key stage like the project initiations, authority approval, construction substage, and the handover. This aligns with industry practice and support the clear practical progress monitoring without unnecessary complexity. For Member 5, it places the milestone at the end of each rebar stage. This provides a clear phase level tracking and is easy to understand but lack detail for identifying issues within the individual task. So, in overall conclusion, the member 4 presents the most realistic and effective milestone approach. It achieves the best balance between the clarity and practicality. This supports the efficient project control without the complexity. For critical path, member 1 has a highly complex critical path with many overlapping activities and minimal flow, which creating the multiple near critical path. This reflects a details and technically through the plan, but increase the coordination risk and sensitivity to delay. The member 2 presents a short and simple critical path focused mainly on early administrative tasks. While it is easy to follow, it is overly optimistic and lack realism as it does not sufficiently consider design, approval, and construction risks. For member 3, it shows a clear and logical critical path progressing through the feasibility, design approval, constructions, and also the MEP works. The including of the MEP installations and testing improve the late-stage risk visibility, resulting in a realistic and manageable critical path. While for member 4, it has a long linear critical path with minimal flow, making it easier to monitoring but highly sensitive to early delays. The task sequencing error reduces the reliability of the critical path despite its clarity. For member 5, it follows a conventional and logical critical path from the feasibility to handover. It is relatively easy to manage but affected by optimistic assumptions due to the exclusions of public holiday. So, in overall, the member 3 demonstrates the most balanced and realistic critical path.
For the comparison of roles, member 1 adopts a less risky management approach by integrating early interval design. Member 1 also enforces on-site safety through a safety officer. Member 2, however, centralizes project control under the project manager. It simplifies communication but risks information loss during briefing stages. However, site supervision support is introduced to assist with the workforce oversight. As for Member 3 adopts a dual management structure which enhances its strategic oversight. However, it is undermined by relying heavily on engineers for planning and construction tasks. Next, we have a Member 4's plan which improves coordination and reduces discrepancies. However, it will overburden a single individual. As such, an appointment of a main contractor will help the project manager in monitoring subcontractors. As for Member 5 enhances coordination and technical execution. However, the relying on an architecture alone raises concerns about the adequacy of comprehensive technical and structural assessment. All in all, Member 1's project plan is the most realistic and achievable. The reasons behind this is for the balanced and multidisciplinary approach, effective planning and cost control, minimization of statutory risks, and assurance of safety compliance.
Right now, I will explain about the comparison from the aspect of resources from material and cost, where for the first member, cost and material plan shows there is no evidence of surplus works or logistical overlap for plant or machinery over the durations. Therefore, the outcome with a theoretical allocations model explains that the materials are assumed to arrive and be utilized effectively without consider the real-life construction constraints. Meanwhile, for the cost plans, the total over than 3 million ringgit shows high-level task record and the actual cost of 0 ringgit. Meanwhile, it creates a challenge as the high overall cost is unsupported by granular resource usage data. For the second member plan demonstrates that the most realistic and professional approach to plan resource allocation, which the duration also shows just in some methodology, and which it ensures that the equipment is only present on site during the specified construction or active phases. Meanwhile, the cost objective adopts a modular budgeting system with a total expenditure of $148,000 consisting of substructure and superstructure. It reflects the WBS cost loading framework that is allowing precise valuations. The third member plan is heavily oriented with materials overseen by a large team of specialized engineers such as electrical, mechanical and structural, which this one led to technical oversight that will be increase the project administrative costs. Meanwhile, the total cost of over 1 million ringgit is dominated by professional fees such as manager, which cover 450 ringgit per day. This aspect can raise concerns about value for money as administrative expenses outweigh direct material investment. Meanwhile, for the fourth member, the systemic over-allocation in material-related roles, for example, the mason involved over than 1,000 hours and brickwork masonry for 1,080 hours. This one creates constraint in the installation phase which leads to the site congestion and risk of material wastage. For the cost from this plan, it presented in large lump sum that showing 630,000 ringgit for the substructure. And when this one presented the lump sum method implemented, it shows that it is impossible to determine the proportion allocated to concrete, steel or labor. It has lack of transparency and which makes the plan difficult and less achievable in practice. The material and the cost plan for member 5 reveals a major imbalance in labor and plant distribution, which is a single worker resource is assigned around 7,000 hours, which consider the specific requirements of different trades such as masonry and carpentry. Plant resources like the excavator are listed. Its contribution is overshadowed by the labor resources allocated beyond productivity requirements. Meanwhile, for the cost plan is amount more over than 1 million ringgit. Meanwhile, the cost details highlight hard remaining costs. It introduced the financial risk, which the absence of clearly defined labor led to increasing of material cost splits and complicates expenditure tracking. Okay, for the conclusion of this comparison, I choose the second member, which is bring the stable result in both the realistic resource allocations and limiting plan hire to specific hours and avoiding unnecessary overheads. It shows that the management is professional, employing modular works that align with the WBS framework. This structures approach and offers both efficiency in resource management and transparency in financial control.
Among the 5 members' project management plan, the member 3's plan is the most realistic and achievable for the Charlotte Sills Gallery project. From the feasibility and practicality perspective, it has a total duration of 316 days, is appropriate for the project skills and the complexity. The phase durations are balanced, which allowing the sufficient time for the design, planning, and constructions. It also have a proper considerations of Selangor public holidays and standard working hours. This enhance the reliability. From the task structure and execution logic perspective, it has a clear and professional dependency structure, prioritizing the client requirement and the design flow. The task sequencing is consistent, with no critical logical error like the constructions, overlapping, handover, or testing. It also have a buffer time is incorporated through the longest task durations. This reduces the scheduling risks despite not explicitly. From the project management perspective, it covers all major stages from the strategy definitions to handover. It also includes the procurement activity like the tender document, evaluations, and award, this reflecting the real industry practice. Besides, the critical path is clear and manageable, with also including the MEP installations and testing that improve the late-stage risk visibility. Although it does not have the milestone, but it does not significantly affect the overall execution's feasibility compared to the other plans with major flows. Now, let's see why the member 3 is chosen while it is compared to other members. The member 1 has the detailed dependencies and role assignment, but it is over detailed and complex. Member 2 have a realistic plan cost allocations, but the sequences or the duration flows reduce the achievability. Member 4 have a balanced milestone, but the others limitations affect the feasibility. While for member 5, it has the ideal task identifications, but optimistic calendar assumptions reduce the reliability. In overall conclusion, member 3 achieved the best balance between the feasibility, realism, and practical project management. It represents the most suitable reference plan for the Charlotte Youth Gallery project.